triangle ABC has sides. Yeah, it's like, just write it like old school. A is 11, B is 21, and C is 13. So which angle would be the largest here? We all like B? Oh, such good learners. So there's infinite number of ways to draw this thing. I'm going to start with the long side down here. I'm going to put angle A there. So that's going to be my long side. B, 21. So this is C. It's got to be 13. And A, opposite angle A, is going to be A, and that needs to be 11. So to do this as accurately as I can, does that look okay? Okay, and again, we're not pulling out a protractor or a ruler and measuring this, but the more accurately you can get your picture, the more apt you are to look at your answer and see, does it kind of make sense? So for sure, does the longest side look like the longest? The shortest looks like the shortest, okay? And the one in between is the one in between. All right, so that's A, this is angle B, and that's going to be angle C, and of course opposite those are sides A, B, and C. All right, so how would you solve this? Well, did you have one of these on your quiz you just did? Can I use sine law? No. I got three sides, that's cosine law, right? Side, side, side. So we're going to do cosine of A is, now which side has to be the minus one here on the end? It has to be little a, yeah. The other two, doesn't matter where they are, 13 squared and 21 squared, but 11 has to be the one on the end, the minus one, because that's opposite angle A. Hopefully you did that on the quiz. Okay, over 2 times 13 times 21, doesn't matter which order. So cosine of A is 13 squared plus 21 squared minus 11 squared equals divided by 2 divided by 13 divided by 21. That's the cosine of A. How do I get angle A? Inverse cosine of that 26.4 degrees. Let's go to the tenths. 1 decimal place. Okay? So far so good? Alrighty. That's 26.4. Now the next thing I'm going to do is get angle B. That's not the one I wanted. This guy. Okay? So there's 2 ways to go about it. Stay with me here. Some would do sine law. And some would go, hey, I just did cosine law. That felt real good. I'm going to stick with cosine law. So let's do it for the people who would use sine law. Sine of 26.4 over 11 is equal to the same ratio as sine of B over 21. Okay, so to get angle B, I'm going to go that times that divided by the other one. Sine 26.4 times 21 divided by 11. That doesn't look like an angle. What do I still have to do? Inverse sine of that ratio will give me the angle 58.1 degrees. Okay, are we happy? Other people might go cosine of B is, which number goes first? Either 11 or 13, right? Those must be your first two numbers. 21 has to be opposite angle B. Over 2 times 11 times 13. That looks like a 12. Let's make it a 13. And 11 squared plus 13 squared. And it's 21 squared. Enter. Divide by 2. Divide by 11. Divide by 13 is the ratio. Inverse cosine of that gives, whoops, inverse cosine of that gives me 121.9. Which is different than the other way. What's going on? Alexis? Ooh, where'd you learn this stuff? Wow. One question and you got it already, eh? Who wasn't here for that? So, here we should have went, does that look like 58 degrees? Remember I asked you which is the largest angle? That would be opposite the largest side. This is the angle. What's the name of this stuff I'm doing today? Ambiguous sine law. What's ambiguous mean in English? Open to interpretation. Double meaning. You have two different meanings here. So, here's what you have to do. If solving for what's obviously an obtuse angle, that's why visually you want to draw these triangles as accurately as possible. Because what happens if you drew yours, like some kids, every one you do is an equilateral triangle. I don't see which one's obtuse, right? Not going to be as helpful, will it? If solving for an obtuse angle using sine law, you must, well, let's just say, do what's 180 minus 58.1? Oh, look. Same one I got with cosine law. 121.9. Okay? So you will get one like that on the test. Treat it like biology. You're going to have to stick it in your noodle, okay? And if you forget that, well, this is going to be your answer, and then that's obviously incorrect, okay? And if you remember it, well, just one little step you have to do. So remember doing this stuff, like kind of where this kind of comes from. Remember the first thing we did? That's 30 degrees. What's this angle? Is that going to give you the same value for sine? Sine of 30, of course, is a half. What's sine 150? Okay, your calculator doesn't know the difference. It doesn't know if you want the acute angle or the obtuse one. Okay, that's ambiguous. Sine law, part 1. All right, so that is obtuse. It's 121.9. If you just use cosine law, you will never run into this problem. There is no ambiguous cosine law. There's just ambiguous sine law. Okay? But if you use sine law, you got to look at your triangle. If it's obtuse, you got one more little step to do. Okay? So lastly then, to solve this, I would just, well, you can use sine law, you can use cosine law, but I would go, what's 180 minus this, and get that angle, right? And it's done, solved. Okay, any questions on that? All right, example 2. Draw and solve two ways. Angle A is 42 degrees, B is 12, and let's see, A is 9. So again, there's tons of ways you can draw this triangle, but I always like to start with the angle down here. So for sure, angle A has to be 42 degrees. Of course, that's 90. Half of that is 45. So that's a little smaller than that. So does that look like about 42? Okay. B could be either the side on the bottom or the side on the top of this angle. I'm going to call it that one. I'm going to put that there. And then A is 9. And that's opposite angle A, of course. Okay? So can you visualize how to draw this? This bottom piece, I guess, is letter C. It doesn't say how long it is. Okay? So it might be that long, it might be this long, might be that long, might be this long. We don't know. But this has to be 9 opposite that angle. So how would you draw this, complete this triangle? How are you visualizing this? What do you see, Ashley? Okay, so it has to be shorter than 12, right? So I can't like do that, but I could do that. Does that look okay? All right, and then that's got to join there to make a triangle. Okay, there's one way. Here's another way. Again, I have to have 42 degrees for this angle. That's angle A. This has to be 12. How else could I draw this? Alexis? Yeah, well, so some of you are going, oh yeah, okay, sure. Another one's going, oh, I don't see it. So this is length 9, okay? I'm not measuring it, I'm just saying that's how long it is. So for sure that has to be 42 degrees. This could be any length I want. I just need to join that point, because this is 12. This is a little shorter than that. I have to join that point to this line somewhere. If I do, I make a triangle, right? So I have it here. Now, could I go over here? No, I can't, because that's never going to reach this bottom line here. I can't bring this line up, because then I'll change this angle. But what I can do is bring it over this way. Can I not? Is that still the same length right there? Right? See how it's too low, too low, too low? Boom, now it touches. Yes, I can draw it like that. So I have two choices. Okay? So that's how it was the other way. So if someone just gave you these numbers, which one would you draw? Is this open to interpretation? Does it have double meaning? Is it ambiguous? You betcha. That's why they call it ambiguous sine law. So there are a couple questions on that one worksheet. I don't know if you noticed when you took a picture of the answers, but it said like there was 2 there, and you might have said, what? That doesn't make any sense. And I said, yeah, we haven't done that yet. Can't do it. Well, now you can. So to solve this, then, what's the only thing I can do? Can I use cosine law or sine law? Again, you need to know on the test. And again, when do you use either? Well, I told you to remember you use cosine law when you got side, angle, side, or side, side, side. Okay? Do I have side, angle, side? No, I have side, side, angle. But visualize, this is the only thing I can do is get that angle right there. Okay? I don't care what the question is. That's the only thing you can do. You have to do that first. So sine of 42 over 9 is sine of whatever you want to call this thing. Let's call it x over, well, I actually got a letter. I'm sorry, that's b. Over 12. Okay? So that times that, divide by 9. Sine of 42 times 12 divided by 9 is sine of b. I want angle b, so inverse sine of that will give me angle b, 63 degrees. So one of those triangles, it is 63, and the other one, it's not. Which one is it 63? Yeah, okay. This guy, yeah, that looks like 63 degrees. I would use that to solve it. For this one, does that look like 63? Definitely not. That's obtuse. I would have to do this same way I just did it, only in that situation, it must be the obtuse option, so I got to go 180 minus 63. Angle B is 117 degrees. Then get the other angle, the other side, however you want it, solved. Okay? That's it. That's ambiguous sine law. There's other ways it can be taught. You can memorize a bunch of stuff. Not a big fan. And that's all the material you got on your test. So I'm going to give you one example here to do. And then 2 questions. On that sine law worksheet. That's 28 degrees. I'll throw the answers up here in a sec for this. So that sine law worksheet I gave you a few days ago. 11 and 12, solve both ways.